Welcome to the deep dive.
Great to be here.
Today we're peeling back the layers on air pollution. It sounds pretty simple, right?
Right, but the material we've gone through shows it's actually, well, incredibly complex. The impacts really do stretch across the globe.
Yeah, they really do. We've looked into, analyses of the actual pollutants, the global effects, how different countries are trying to respond.
Mhm.
And our mission really is to pull out the most important nuggets, the key facts, maybe some surprising bits for you, and get you informed fast.
And maybe start with a big one.
Let's just picture this statistic that jumped out. An alarming 99% of the world's population
99%.
is breathing air that goes beyond the World Health Organization's safety limits for pollutants.
Wow, that's almost everyone. It's a staggering baseline to start from.
It really is.
So, at its core, air pollution is, contamination. Stuff in the atmosphere that shouldn't be there. Chemical, physical, biological agents.
And it's coming from everywhere.
Pretty much. I mean, household stuff, cars and trucks, industry,
Yeah.
obviously. But even natural things like forest fires are big sources.
Okay, so let's dive a bit deeper then. The data seems to show it's not just one simple thing called pollution. There's a distinction the sources make. Okay, so let's dive right in. At its core, what's the fundamental difference? Primary versus secondary.
Okay, think of it this way. Primary pollutants are, well, they're the direct offenders. They get emitted straight from a source, already in a harmful form.
Yeah.
So picture smoke from a factory chimney, exhaust from a car's tailpipe, or, even smoke and particles from a wildfire. They are what they are, right from the moment they hit the air.
Right, so they come out of something already bad. Can you give us some examples some of our listeners probably heard of?
Absolutely. We're talking about things like particulate matter, especially those tiny PM 2.5 particles from burning fuels. They're so small they get deep into your lungs. Then there's carbon monoxide, silent, odorless, comes from incomplete combustion. Sulfur dioxide, mainly from burning coal and oil. Nitrogen oxides, too. They're formed during high-temperature combustion, like in car engines or power plants. And volatile organic compounds, VOCs. They evaporate from solvents, paints, gasoline, things like that. Even some formaldehyde can be primary.
Okay, so those are the first-degree pollutants, you could say, directly released. But
Yeah.
then you get these shapeshifters, right? The secondary ones that form in the air.
Exactly. That's a good way to put it.
Yeah.
Secondary pollutants are not directly emitted. They actually form up in the atmosphere. It happens when those primary pollutants we just mentioned react chemically. They react with each other or maybe with other natural things in the air. And often this whole process needs a kickstart, like sunlight or water vapor.
And that transformation, that chemical change, that makes them harder to deal with directly.
Generally, yes.
Yeah.
Much harder. I mean, you can put a filter on a smokestack to catch primary particles,
Huh?
right? But you can't really put a filter on the sky to stop chemical reactions.
Mm-hmm.
So you have to go after the ingredients, the precursors, those primary pollutants that become the secondary ones.
Okay, this is where it gets really interesting for me. These secondary pollutants are actually made from those primary ones. How does that work? Give us an example.
Well, maybe the most famous one is ground level ozone. That brownish haze you see in smog.
Hmm.
A big part of that is ozone. And it forms when nitrogen oxides and those volatile organic compounds, the primary ones react together, but they need sunlight to do it.
Ah, sunlight is the trigger there.
Precisely. Then you've got acid rain. That forms when sulfur dioxide and nitrogen oxides react with water up in the atmosphere. And here's something really key. A lot of the particulate matter people breathe isn't just dust or soot directly emitted. A significant chunk of it actually forms in the air from gases like SO2 and NOx reacting.
Wait, hold on. So the same primary pollutants like NOx and SO2, they're not just bad on their own, but they're also building blocks for multiple other pollution problems later on.
Exactly. NOx, SO2, and VOCs, they're the main precursors. Think of them as the key ingredients for ground-level ozone, acid rain, and a big slice of that secondary particulate matter pie. And this insight from the research, it's powerful. It means cutting down on these specific primary pollutants gives you this huge synergistic benefit. You tackle several pollution problems with one move.
Okay, that really clarifies the difference in how they form. But let's zoom out. What does this all mean for you, the listener? Why should we care about this distinction for our health, for the environment?
Oh, the impacts are massive and very personal. When you breathe these pollutants, primary and secondary, they cause damage right down at the cellular level. We're talking lungs, heart, even your brain. That tiny PM2.5 we mentioned, it gets deep into your lungs, even into your bloodstream. It's linked to respiratory issues, sure, but also heart attacks, strokes, COPD, ozone. It directly damages lung tissue. NO2 makes you more susceptible to respiratory infections. And, the sad reality is the burden isn't shared equally. Children, older adults, people with existing conditions, they're more vulnerable. And studies consistently show low-income and minority communities often face higher exposures and consequently greater health risks.
And it's not just human health, is it? The environment takes a beating, too.
Profoundly, yeah. Acid rain damages forests, makes lakes and streams too acidic for fish and other life. It even eats away at buildings and statues over time. Ground-level ozone. It can actually reduce crop yields, damage plants, impact entire ecosystems. And all that particulate matter creates haze, reducing visibility even far away from cities. And here's the connection that really ties it all together, the critical link. Many of the big sources of these air pollutants, think burning fossil fuels in power plants, cars, industry. They're also the main sources of the greenhouse gases driving climate change. Plus, tropospheric ozone, that secondary pollutant we talked about. It's actually a potent greenhouse gas itself.
And the sources said these are harder to deal with.
Much harder, yeah, because they form after the initial pollution is released, and crucially, they can travel really long distances on the wind before they even properly form.
So it's not just my city's problem. It could be coming from hundreds of miles away.
Precisely. It really highlights that this is a transboundary issue, crosses borders.
And the impact on us.
And buildings.
And something I hadn't heard as much about, eutrophication.
Yeah, that's basically excess nitrogen, often from air pollution, getting deposited onto land and water. It disrupts ecosystems, changes what plants grow, and causes those nasty algal blooms in lakes and seas.
And food. Does it hit our food supply?
Directly. The sources detail significant impacts on agriculture. Ground-level ozone alone, just that one pollutant, is estimated to cause losses of around 110 million tons of major staple crops every single year. That's food off the table.
So, faced with all this, what's being done internationally?
Well, we looked at the global response.
Mm.
It's fragmented. There isn't one big single treaty just for air pollution with binding rules for everyone.
Mm.
Efforts tend to be folded into broader things like the Paris Agreement on climate change.
But there have been successes. The material mentions some.
Oh, definitely. And they show change is possible. Look at the U.S. Clean Air Act. It led to really significant cuts in emissions over decades. And globally, the Montreal Protocol was incredibly effective at phasing out the chemicals that were destroying the ozone layer. So targeted action can work.
And technology must be playing a bigger role now.
Hugely. It's a game changer. You've got tiny low-cost sensors now, satellites watching from above, big data analysis pulling it all together.
So we can see it better.
We get real-time, high-resolution data. We can see where the pollution is, how it's moving, and target actions much, much more effectively than before.
Okay. So pulling it all together from this deep dive, air pollution isn't just, visible smog.
Not at all.
It's this pervasive, complex challenge. Devastating health effects, major environmental damage, and it hits the most vulnerable people the hardest.
Yeah. Addressing it really needs joined-up thinking. Policies across different sectors, transport, energy, industry, agriculture.
And stronger international cooperation, right? Because it crosses borders.
Absolutely. Plus, using all that new tech and data and keeping the public engaged and aware. It's really fundamental for, sustainable development.
Oh, it truly is. Okay, here's a final thought for you, something that really stuck with me from the analysis. Mm-hmm. For some of these pollutants, there's actually no safe level, no threshold below which they stop being harmful. Even low levels can cause problems.
Right.
And we know it travels across borders. It's often invisible.
Yeah.
So given this pervasive, invisible, borderless threat, what does being truly well-informed actually mean for the choices you make day to day?